and welcome everyone to our second Hack Responsibly podcast or videocast. And we have a slight participant change up. We're swapping out Scott Sutherland from last time with two subject matter experts on blockchain and distributed ledger technology. I'll let them do formal introductions for themselves, and maybe we can start with Hannay, and then we'll wrap up with me and Karl for one last reminder.
Hey everyone, hi, I'm Hannay. I'm a security consultant at NetSPI. Pretty broad background, apps, infrastructure, cloud, mobile, but recently I've gone all in on blockchain and smart contract security. And I guess, we're just going to talk a little bit about that today.
Awesome. Connor?
Hi guys, I'm Connor. I'm a security consultant. I've been at SPI for a little while. I focus mostly on blockchain, smart contract auditing, but I've got, like Hannay said, I got a background of a lot of different stuff. So, but right now my focus is blockchain.
Awesome.
That's me.
Karl, a little reminder for the audience.
Sure. So Karl Fosaaen, VP Research, NetSPI here. Been at NetSPI for quite a while, done a lot of different things during that time, but primarily pen testing, application and network, and focusing a lot on the cloud.
Awesome. Yeah. And Nick Landers, I work on the same team with Karl, and my historic experience tends to be in malware development and Windows side research. But recently been spending a little bit more time on the blockchain side. Super excited to chat with these guys about what they've found. Predominantly, the conversation I think will center around a series of blog posts that are discussing the internals of what's called the Ethereum Virtual Machine. This blog post was kind of authored predominantly by Hannay, and Connor, I'm sure, can provide some great commentary there. But I think more broadly, it would be great to just chat a little bit about, how NetSPI thinks about blockchain security or DLT, how we think about our testing methodologies, what direction we maybe see the technology taking. So I think maybe a great place to open it up would just be Hannay, and I'll give you the floor to maybe do a little introduction on the blog posts that are coming out, chat a little bit about maybe why you wrote them and what you're hoping to communicate as a function of that. And we can start diving into some details. Does that sound good?
Sure, yeah. So for about a month or two ago, we said we need to really get some more blockchain content out there. So I thought, okay, just Ethereum Virtual Machine internals. That would be something that we could be relatively quick and easy to get out. And then probably about 80 pages later, I got part one out, which I believe is one of the longer blog posts we have. So
yes. Yeah,
I've learned a lot.
They got pretty eccentric in the length, but
yeah. So it's kind of like, so imagine like, because you know how something works and then you try to actually explain it in a comprehensive way. There's that element of it, and then also like there's a lot of Solidity, which is the high-level language used to write smart contracts, and the Ethereum virtual machine itself. It changes so rapidly in the years it's been out, especially in the last couple of years, and the technical resources out there they're either all spread out and with the different versions being described and slight differences in the concepts being described, and then I didn't find that many sort of like coherent step-by-step ways of like deep dives. So I thought I might as well come with one myself. And like the primary audience is pen testers who have sort of like a cursory understanding of smart contracts, but kind of like how you might skip the like being well versed in a high level language when you're doing something like exploit development and go straight for assembly. I try to kind of like do the same here and go into considerable detail about what's going on under the hood once you submit a call or a transaction to a smart contract. That's basically it. It's a bunch of fun stuff in there.
nice. Yeah, I've read through quite a lot of the drafts, and they are beefy, to say the least. And I'm with you about like the comprehensive sort of collection of resources. It feels like, especially in the blockchain space, but a lot of tech spaces are kind of prone to this. It feels like there's a lot of research out there, but not good singular locations to find it, and certainly not large, sets of information that are authored by the same person or a small group. So you get tone shifts when you switch between topics, and it feels like you might find a tone that really fits with you. And you read another blog that's describing some other component, doesn't really work out. Yeah, do you have like, we'll probably get to maybe conclusions later on, but just to get people thinking about what they'll get out of these blog posts, do you have maybe like 2 or 3 key points that you think security people will take away? Is it you predominantly covering just raw internals and contextual knowledge? Do you feel like you're maybe in some sense trying to make a point about how to understand these sorts of internals and how to contextualize them in a security frame? Are you trying to make it practical? What was sort of the context goals?
Yeah, well, what I didn't want to do was just have like another like here's a top 10 Solidity vulnerabilities. Like those are good, but there's loads of those. So what I wanted to do was sort of like show why certain things are the way they are in high level Solidity, and what you need to know as a contract auditor to really really take advantage of many quirks and flaws inherent to the EVM. I think there was a base. So what made it kind of difficult to write was I made the decision to base everything on one contract, which had this kind of like esoteric but really cool vulnerability. And I didn't see, it's kind of like a memory corruption vulnerability. Maybe go into it later, but I didn't really see anything else out there that described it, and it described or exemplified like how memory really works, like volatile memory really works in the EVM. So I just kind of like ran with that. So yeah, in short, it's like trying to get across what happens after what really happens from start to end as much as I can in the execution context when you execute a smart contract method.
Right. Awesome. I guess maybe we'll jump over to Connor. You have a lot of industry experience in blockchain. I know you came from security consulting before then. When you have maybe read through the drafts of some of these blogs, or maybe when you've tried to learn about the internals of these virtual machines before, especially in a security context, is there like lacking components or maybe a mentality that somebody's bringing to the table when they talk about these sorts of internals that's focused on parts of maybe the crypto space or something that's semi-adjacent to security consulting, but not really well-grounded? Just curious to get your thoughts on maybe comparisons, seeing a blog like this come out of a dedicated security group as opposed to more just generalized research or an auditing firm.
Yeah, it's an interesting one because there's a lot of documentation, a lot of blog posts about Solidity and EVM and the generics, but there are very few resources that kind of go into the really nitty gritty, the sort of peeking behind the curtain that we want to do as a consultancy and looking at it from an audit perspective. It tends to be a lot more high level and just kind of like, yeah, memory, it just works. EVM just works, but this is how you would do X in Solidity or Viper or whatever the language is. So I think having something that's really concise, like Hannay's post, which really breaks down like each step and sort of guides you through the entire process, but at a deep level, it's something that's really valuable in the space, and kind of from having that security perspective throughout the entire process as well, kind of helps to highlight some areas that maybe people would have missed just reading through the documentation or the white paper or however they're kind of getting the low level information. So I think it's something that's very, 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 very valuable in my opinion.
Yeah, I'm drawn to this. Reading through these internals blogs, you arrive at a lot of very natural questions. And I think a lot of those questions, for me at least, center on, is this always the case? Is this a specification that's applied broadly? Because in like traditional technology and a lot of this tech that, certainly at least myself and Karl have spent a huge amount of time looking at, these technologies have been around for such a long time that the specs and the standards and the RFCs are super firm, right? It's like, your interpretation of an MS SQL server is pretty much the same no matter where you go. And in terms of researching that, you can look at a spec and make a pretty strong assumption about like what's going on underneath in the actual code. Oftentimes the specifications are written by the company who built the technology, right? It's like there's a single entity, Microsoft, and they build a protocol and write the spec for it. When I read through these blog posts, and I've talked to Hannay a lot sort of passively, I would arrive at areas of the EVM or Ethereum where I'd have a question, and it felt like the documentation or the specification wasn't particularly clear on how to handle that. And there's a few different implementations of these EVM environments and sort of node environments that run the Ethereum process. I'm curious if maybe Hannay, if you want to talk a little bit about how these sort of specifications are different than others that you've seen in the space, and how there's almost maybe some hidden nuance in the way that they're implemented, and maybe assumptions people make about the way memory is stored or the way storage is performed that isn't explicitly spelled out in certain areas.
Yeah, I mean, like, so in general, like blockchain it's kind of just a bunch of dudes, It's not like there are companies or DAOs who come with their own specifications, but like you have to keep in mind, like the first guy who came up with this was he's 15 years old, Vitalik.
Mm-hmm.
I don't know what I was doing at 15. Not that, like it's definitely
not writing a blockchain. I'll tell you that much.
No, I was like barely sentient until I was like 21. But like he was like, this is like, it almost has to be kind of like loose, because there's no, it's not meant to be like people are meant to come up with their own implementations. It's obviously like meant to follow, like there are standards in that if you implement it wrong, you just won't be able to, whatever validators are running your implementation just won't be able to add to that.
You won't be able to participate, essentially.
Yeah.
It's kind of like participation is driving the standard, but that's a really interesting way that we haven't done that in very many other parts of tech, right?
Yeah. Like what actually like drives the network as a whole is, I mean, for Ethereum now, it's MEV, used to be minor extracted value, now it's maximum extracted value, which is how much you can, as a miner, stand to gain from ordering transactions in a certain way, which is inherently selfish on first glance for a miner, but that's the way that the network is secured. So there has to be kind of like room for interpretation. Because at the end of the blockchain is a massive adversarial network, and people have to like the way it can't be structured as like as static as like an RFC or something like that. And also like because it changes so quickly, and fundamental things sometimes change. Like the move from proof of work to proof of stake in the merge, and then you also have to allow for things like forks, which is when the network just goes completely way off in another direction. So yeah, it's very fast and loose, but I think that's just what you kind of have to get used to when you're doing blockchain stuff.
Cool. Yeah, I guess Connor or Karl, do you have any kind of responses or additional thoughts on that vein?
Yeah, I think from being in kind of industry for a while, it's probably the most fast-paced environment I've seen in tech. It's kind of, things are changing so quickly, especially during the bull runs. New projects are coming out. There's a lot of innovation, but kind of with that innovation comes a lot of pitfalls, a lot of areas that maybe aren't looked at at the same level as something that's been around for, say, 10, 15 years, right? So yeah. I'm sure that there are things that are around now that people haven't had time to look at because it's just so new, right? So there's a lot of areas of really cool research that can be done in the space, and a lot of value that could be added outside of these projects that make people money, or give people access to projects or resources that they wouldn't have access to otherwise. So it's an interesting one, and definitely definitely keeps you on your toes as well. You've got
Right.
to kind of keep your finger to the pulse.
Cool. Yeah, Karl, anything from you?
To me, it kind of feels like another layer of complexity on top of everything else we already have. We've got network security, we've got application security, we've got cloud security, we've got all of these other things that we got to focus on from a baseline perspective. Oh, and then on top of that, we got to secure everything that's handling the DLT, the technologies around that, the application code issues, all that kind of stuff in that actual technology on top of all of that. And it feels like we're just adding complexity to already unsolved problems and just adding additional attack surface area that we need to deal with. And it's all cool stuff, don't get me wrong, but it really complicates that paradigm of, traditional application security. We've got, 3-tier architecture. We've got these things to think about. It's not solved, but we've got really good ways of going about protecting those things.
Right.
Okay, now let's throw additional technologies on top of that to further complicate the model and makes things interesting for us.
Yeah, I'd agree. And I think like it also moves so quickly that even you and I are known to specialize in certain fields. Like you can't keep up. I mean, AI or machine learning research could be an equally applicable analogy in many ways. It's a new technology I'm sure we'll chat more about on the show, but the trajectory and the pace at which it scales on top of technology that we already don't entirely know how to like properly secure can be a little overwhelming. But yeah, I think all those thoughts are great. I suppose maybe more broadly, and I'll spin it back to maybe we'll go back to Connor. When you think about the DLT security space in general, and this research obviously is a reflection of our sort of exploration of that space and our attempt to produce useful materials, but also attempt to capture like a methodology for thinking about DLT security. What components or main ideas are you drawn to when you try to think about like how to communicate DLT security to customers, or maybe what gaps do you see in the way people are thinking about this technology that leads them to maybe pursue security in the wrong ways or with the wrong focal points? And we can kind of go Connor first, and then Hannay can add some follow-up thoughts.
Yeah, so one thing that you see quite often, they started to change a bit now, but the focus was primarily on the smart contracts. So the code that was actually run on chain and did whatever they were looking to do. And kind of the supporting infrastructure was not ignored, but these projects come in so fast that they're just spinning up EC2s in AWS and just firing out what they need to get the service running or to support the project, but not being able or not having the experience on the security side to be able to look at that and find the misconfigurations or the common pitfalls that you don't see as often in sort of the Web 2 or the classic space. So I think that's something that there's been a number of attacks in the past year or so that have kind of targeted that underlying infrastructure, because it's a softer target, because there's more tools available, there's more techniques that are well known, just more attack surface. So
it's kind of less abstract too. It's got like more generalized components that people. I don't know, there's some element about technology where the more abstract it gets, or the way people are interacting with the abstractism, just deploy this machine onto a box and like don't think about it, or I'm working in like this high level space where I'm writing contracts, I'm not really concerned about the security. But like when you actually implement it, that's like where security bulbs are introduced. So you think like, oh, I'm using this security, as long as I'm using blockchain, it's secure. But the reality is like you're not, because there's still a server with configuration and nodes, and there's tons of mess ups you can do along the process.
Yeah,
absolutely.
For what like when you're assessing like a web app or a network or reversing something, what I find is like it's kind of easy to look like what you're working with. You can kind of look down and be like, okay, it's this app, it's this like this subnet. When you're doing like smart contract auditing, you have the application itself, but then there's once you can have like a smart contract which is quote unquote bug free, but then you deploy in the mainnet and then it gets front run instantly by a medbot. Because there's a whole
can you
other
actually explain front running or give the audience a quick? I find that really interesting, and I think not a lot of people are exposed to that.
Yeah, so like front running is so it's kind of like a design. It's not a design flaw. It's just the way that blockchain, not all of them, but Bitcoin and Ethereum in particular, before transactions are validated, they are publicly. You can see them publicly in basically like a list. It's called a mempool. And what front running is when, say, you're an attacker and you see someone buying putting an order in for a certain token, that transaction, that order is going to give the miners some what's what I'm looking for? Some
like information or context.
No, it's a very simple word. I don't know why I've gone profit. So like you get a profit, like a reward for like mining something. What you can do as a front runner is put in the same order but with a higher reward. So the miners validate your transaction first, and then the other guy's transaction is going to get ordered. So, but which doesn't sound like much, but in doing that, you can sort of create a loop where you can push up prices of a digital asset, and then by doing that, you could increase demand. And then once leverage comes into play, there's all sorts of like financial attacks, which the smart contract itself, there are some protections against front running that you can put into a smart contract. But it's kind of just one of those things that you have to be aware of is going to happen. Many DeFi breaches have been due to things like front running and some of the things like a sandwich attack, which is when you try to sell the asset back to the original guy, and then therefore you net a profit. But yeah, you can't really you don't really know that these things are possible just from auditing a contract. And that's kind of what I was trying to get at before. Like when you're doing smart, you really have to be aware of this whole abstract thing that is a blockchain, not just the code that you're looking at.
Right. Yeah, I think you had shared a great blog post, escaping the dark forest, if I remember correctly. And it's really interesting commentary on, it's like even when you're attempting to exploit a vulnerability in a contract, it's like in traditional exploit development, you could do things in pretty heavy isolation, right? It's like worst case, maybe you're sending traffic across the internet to a single server and it would get like dropped in their logs. But if I have a vulnerability I want to try and exploit, I can effectively try that in isolation and verify that it's going to work. And then when I want to use it in the real world, it's really only me and another party that's involved. But in the case of blockchain, it's like the minute you submit a transaction that would exploit a contract, that gets like put in a public pool and somebody can find it and then exploit the contract themselves before you, just by like recreating your. So it's like there's this massive container of all the transactions, and you expose or leak information about everything you're doing before it's actually executed on the chain. I think that's a great example of that like abstract detail kind of coming back to bite you if you don't actually understand how these networks work. And I think, would you agree that a lot of security vulnerabilities in these contracts kind of stem from that? It's like nuances in the way that contracts can chain other contracts with like reentrancy, or the nuances of different virtual machines processing it, front running, stuff like that.
Yeah, I think so yeah, the interaction between contracts is between contracts and then kind of more broadly other systems, which might include traditional Web 2 systems. That's where the real juicy vulnerabilities are. A good example, I think it was in February 2021, there was this DeFi protocol. It was called a Furo Combo, and it was basically like Scratch, the GUI programming language for DeFi, like very like block based, but like, so the issue was that one of the contracts it used like an allow list for methods in other contracts that it was allowed to execute, and it executed that via this nifty but highly risky way of calling another contract, which is delegate call, which is basically you use another contract's code just as a library, but you execute it in your own context. So
Okay.
they had an allow list, and like the contract itself was fine. They had an allow list, and it so happened that the allow list contained another contract which had this delegate call mechanism that was not initialized. So the attacker, he had like a small window to initialize this allow listed contract in the content, and therefore it will be executed in the content. It basically be like signed code that will be executed in the base contract, and he's able to have this like delegation chain. And yeah, it was, I think it's like 15 million or something that he walked off with.
Cool. I want to or I have a query to Karl that I thought of, and this is an analogy that I use a lot, maybe poorly. You've spent a lot of time in the cloud space and seen it grow from something that in its really early days was kind of projected as like this savior of technology in a strange way, right? Like this huge, paradigm shift. And I remember when I was, learning cloud security, it was always pitched in this frame of like, come learn what's going to change tech, or like people are moving to the cloud. It became like memes and jokes, and it had the pop culture associated with it. Now we've kind of settled, we're probably, what would you say, like 15 years or so past like major cloud shifts, maybe only 10 years past major adoption. When you look at this DLT space, are you drawn to like analogies in your mind, and maybe is making the comparison between this technology and something like cloud that will spike and merge and settle a viable one? Or do you think that that's actually maybe inaccurate and that there's something fundamentally different about this tech?
I think in a lot of ways it is a kind of a viable analogy. We've got to give it a little bit of runtime, kind of see where things shake out and things change. Where I think we have some differences, cloud, it's really just a computer in somebody else's data center, right? You don't really have the financial impact that you would have with kind of smart contracts or any other kind of currency-based DLT.
Right. There's not like an economy attached to them.
Right.
It's really interesting.
Yeah. So I think that kind of caused a little bit of a breakdown there, but I mean, you could probably further abstract it into kind of the banking space, right? Like checks became a thing, right? You needed to have security around checks to make sure that checks were printed by proper banks and could be verified for authenticity, all those kind of things. I'm sure you could extend those kind of analogies there.
Right.
But
like
from
the
a
check fraud runs of like early bank days, where just like the physical limitations of getting checks from one bank to another means you could like create an endless. So there, that's a curious point. There's like unique vulnerabilities in any technology, especially when it's sort of finance related. And I think there's maybe a longer term settling of those, just because finance is it wants to be so rigid. It like needs things to wants to give things time to conform.
Well, especially with the quick adoption of this, like early days of Bitcoin, you would see a whole bunch of places like, oh, you can order pizza with a Bitcoin, right? Like the quick adoption of a lot of this stuff, I think, is accelerating finding those vulnerabilities, exploiting them, and fixing them. So compared to check fraud, which probably took 10, 15 years at a minimum to kind of start getting a handle on, we've got maybe 10, 15 months to kind of start getting through some of these vulnerabilities with cryptocurrencies.
Right.
Repairing some of that. Yeah. But I always kind of fall back on shared responsibility model. From a cloud perspective, the cloud providers have a responsibility to secure their computers, their code, the services that they're offering, and it's your responsibility to securely deploy things and configure things properly so you're not exposing yourself out to the internet unintentionally. There's that concept of a shared responsibility model. I think with DLT, you've got something kind of similar in terms of you've got that core technology of how everything works. It really comes down to your implementation of it to really figure out if it's secure or not, or if you're securely deploying it and making it vulnerable out there in the process.
Yeah, nice. I'm drawn to a thought about that, or an extension of that, which is, that I'd be curious to get Connor's thoughts. in the DLT space, we've certainly, there's a huge pool or like bubble around the crypto token space, right? Especially the Ethereum chain and the Bitcoin chain. These public chains where you are kind of abstracted away from a lot of the technologies, and predominantly security is really focused on contract code and the sort of high level abstractions you're running on top of it. But we've seen a huge number of financial institutions and larger groups looking at this technology in slightly different ways, not in one that involves like public chains, but ones that involve private chains or even completely separate chain technologies like Hyperledger. And we've had kind of casual conversations where we talk about it's surprising the lack of security research in those different chain technologies, just maybe driven by like the popularity of the technology. I'm curious if you have any like immediate thoughts there, and maybe how would you frame all of these technologies against each other? And if somebody's watching this who's a security researcher or someone maybe interested, maybe they do contract auditing, but they're looking for more challenges, what technologies would you point them to? Would you say like, hey, go learn this? Maybe it's an EVM internals thing, maybe it's adjacent. But yeah, what are your thoughts there?
Yeah, I think the difference in sort of like the maturity of research in sort of the private chain space versus public comes down to motivation, right? There's a lot of motivation for maybe younger audiences or more experienced hackers to kind of really get involved on the public chain because there's a financial benefit if they're successful.
The
I
bug
mean,
bounties are built in, right?
Exactly, right. We're not even talking about like the actual kids who 15 mil, right? And then regret it instantly, like we saw in Bank a couple of months back.
Right.
But even just bug bounties, like as a security professional, you can make some good money if you can kind of get your head around the core concepts. And I think that's really, really nice, especially considering still relatively new in the Web 2 space. Like there's a lot of people who don't go into that bug bounty research side.
Right.
So I think there's a just kind of getting stuck in the laurels from the sort of getting involved and learning more, and just really understanding the technology that you're most invested in, either emotionally or from an academic standpoint.
Right.
So I think there's definitely Ethereum is where a lot of the money is currently. But if you start looking at some of the alt chains like Cardano or Cosmos, or there's these Tendermint chains that are cropping up, there's some really cool technologies and techniques and kind of differences between the two. And there's a lot of really interesting research work that is still left to be done.
Do you
Yeah,
think the Ethereum space is, or at least maybe the public contract space focused on Ethereum, but more broadly like smart contract auditing, do you think that that's had like more security research than an average technology as a function of it being financially driven? The bug bounties built in joke. Do you think that there's something to be, I mean, I'm sure there's something to be said about the fact that the technology is pacing quickly, and Hannay brought that up earlier. But if somebody were really looking to find novel vulnerabilities, do you think that maybe there's a reason you would choose a more esoteric or lesser known chain just for the chance to find something super novel, as opposed to hanging out in the space where all of the security researchers are spending most of their time? Or do you think maybe that's an improper characterization and that there actually still is a ton of stuff on all of these technologies?
I think personally, I think there's still a whole lot left to find. I think we're kind of in the period of, if we go back to Web 2, where SQL injection was starting to become a well-known bug, right? And people were like, everything's vulnerable to it, the world is on fire. And now if you think now, 10, 20 years later, we still look for that, but it's a lot more rare. And the type of vulnerabilities that are more common now are maybe a little bit more complex or integrate with technologies that didn't exist. So I think that there's still
like SMS 2FA and IDOR, and like there's entire authentication layers that get stacked on top of Web 2 that didn't used to exist. And you have like JWT tokens and local session storage and OAuth integrations. So Right.
Yeah.
You're arguing that there will be like more technologies that will continue to stack, and like the really simplistic common vulnerabilities that we'll see today will still be around, but in sort of nuanced form. And what we'll really see is like, you know, brand new higher order vulnerabilities that are a function of its relationship with other tech. Did I capture that properly?
Yeah, much more succinctly than I did. So thank you for that. I think that things like re-entrancy, take it's the buzzword on Solidity, right? EVM. You don't see it as now because there are well-defined development patterns that prevent it. You've got Open Zeppelin's re-entrant libraries, or you can build it in yourself. So I think that is starting to be less of a common finding. It's still like there's still room for mistake, and there's still lots of new developers coming in. But I think that the big difference is back in Web 2, when everybody was building PHP apps, everybody was using the same tutorials that had zero focus on security, right? It was just
Right.
here's how effectively to build a vulnerable SQL injection TTF, right? That's what it was. Whereas the development guides in crypto, they tend to kind of bake in that idea of we want to be secure by design, rather than having to try and tack it on with frameworks and kind of not make the mistakes. But I think that there's still so much depth and complexity there, even just on the single chain, that
Right.
things are going to be, I think, look very different in 5 years' time from a security standpoint, from auditing. We're going to be looking for the same things we do now, but there's going to be more, you know, a good way of explaining, I guess, is flash loans. They weren't a thing maybe 5 years ago, but now it's something that you need to think about when you design a project, right? The idea that somebody can go get a extremely large loan, and as long as they can pay it back quickly enough within, say, one block, they don't pay, and it's like a free loan, and they can use that to attack contracts or liquidity pools or whatever the financial gain they can get out of it. And it's all completely legal. Gray area, let's say. There's not a lot of control over sort of like market manipulation or doing these big moves like there is in, say, fiat currencies, so like the stock market. So I think that as new projects are kind of cropping up and coming up with new novel ideas, there's always going to be new vulnerabilities that kind of come with that. And that's not even, branching out into, say, other complete different technologies within blockchain. There's a lot of people doing a lot of really interesting stuff. One is Bitcoin. You don't have smart contracts on Bitcoin; it's just static value. There's maybe 3 or 4 projects that are actually, subverting that. They're building solutions to be able to run smart contracts on Bitcoin, right? Because there's so much value locked there. Why not use your Bitcoin to run smart contracts and make Bitcoin great again, right? So there's going to be so much change, especially as we're coming into potentially a new bull run. That there's going to be a lot of funding available and a lot of innovation in this space. And that's not even going into sort of the zero knowledge proof layer 2 sort of abstractions that make these faster. So I think it's a really, really cool space to work in. And it kind of, tickles that ADHD part of your brain that needs to constantly be chasing the dopamine, right?
Yes, yeah, absolutely. Hannay, any additional thoughts on that? I'll move over to maybe a wrap up in a little bit, but I wanted to give you a chance to capture some thoughts on whether or not the security space is tapped out or not, and your kind of opinion.
Yeah, no, I don't. I think one of the at least what I found when getting started is that the blockchain space, and particularly blockchain security, so really smart contract auditing, is quite insular. And you have people who are, especially now, in the last year or so, have no security experience. Some of them have no development experience, but they've just really gone all in on smart contract auditing and are doing amazingly well. At the same time, you don't really see, like, there's not that many the people who do blockchain security, that's basically all they do. I think what we're trying to do differently is we've been doing security for about 20 years. And it's kind of the surrounding infrastructure and the things built around it, like the wrappers around blockchain technology, which is it has to be wrapped in something to be as adoption increases. That's where like there needs to be more sort of like people who are looking to take what they know from both worlds and integrate into one, because that's where the real vulnerabilities are, not only in smart contracts themselves, but like the integrations between them.
Nice. Yeah, that's great. I love that. I think existing on the edge of two different areas of focus is always an excellent way to provide value. I give that as personal advice to individuals wanting to push themselves as researchers, but I also think in tech spaces, it's just such a great position to be in. If you can bring contextual knowledge from, traditional security and traditional technologies and new sort of fresh knowledge of Web3 technologies, and bring them together, you might be able to exist in an extremely valuable space where not a lot of people would be, right? Like not a lot of people span that edge. I think we'll maybe wrap up with final thoughts. And this is maybe a topic that we didn't get to touch on a lot with Hannay and Connor. Obviously, these guys are incredibly talented with a distributed ledger technology. They know a lot about blockchain and a lot about its security. But I'd maybe like to do a roundtable and ask people what advice you would give to individuals wanting to do more research in this space. Maybe they're traditional security researchers and they haven't spent a lot of time with Web3, or maybe they are almost exclusively Web3 developers, but they're trying to understand more like traditional security contexts or traditional security research. And maybe, I guess, Connor, do we want to start with you, and you can give your advice or opinions to anyone out there who might be watching this and feel inspired to look at this technology? Because I think what we've established is that there's a ton to look at, right?
Oh yeah, absolutely. I think that the big thing is don't let a cost of entry put you off. So a lot of people feel like they can't really get into the nitty-gritty of the crypto space without, holding up the funds. And especially if you don't have the sort of disposable income to be able to go and try out liquidity pools and see what swapping is. I think it's a big mental barrier of entry, but I don't think it should be. I think that there's a lot of information, and if you're willing to sit down and read or do CTFs or just watch YouTube videos on how does crypto work, what is distributed finance, and kind of having that base is really good for getting a good understanding of where if you're doing, say, like a threat model of a project that you're interested in, like where is the value moving, and how as an attacker I would sort of go after that. I think that is very much a skill that you can pick up from the classic pen testing world. You look at the web app, that's kind of what you're doing already, right? You're looking for those areas where what's interesting, where can I move value, or where can I pull out valuable information. So I think that would be my big takeaway is kind of just, if you're interested in the space, just get stuck in. Don't worry about having to put money up and get involved in the actual economic side. There's plenty of resources out there, especially the Hannay's blog post. If you want to get involved in the really deep underlying Ethereum like fundamentals and internals.
Yeah, and that's all done, in just Brownie and Remix, and you can deploy local environments and on test nets. I think that's great advice. Is that I found that in a lot of areas in this space, and it's the same with a lot of technologies as well. There's complicated terminology used to describe things, and maybe you hear the term like swap or maybe a particular type of token. But once you hear the concept explained to you, it's really obvious, right? Like what in a lot of times they're reproducing is just really primitive financial instruments in a digital space. They're giving them new names, or they have like nuances to them by the way they're developed. But I think right now, like a lot of it's way more approachable than you would think. It all kind of clicks and makes sense. You only need a few building blocks before every subsequent tech after that is like, oh yeah, that's a smart idea. Like I could see that being done. Karl, do you have any, maybe a bit of an odd person to ask advice for, but do you I don't know, maybe read through these blog posts or listen to these guys talk and think about areas where you could be applicable to the space, maybe areas where traditional pen testers might be, or do you think that there's just broad advice you'd like to give for those who'd want to explore such a nuanced and like sort of detail oriented space that's very new and evolving?
Yeah, I'm still extremely novice in the space, learning it as I go and getting more into it. You have all been great resources to learn stuff from. It's very informative for me. The big takeaway I've kind of had with it over the last handful of years is looking at how it's being adopted. You know, you got multiple different technologies that you're working with. How are those technologies being utilized, and what's the practical application? You know, we kind of talked about like checks and banking and that kind of stuff, and how those technologies kind of mirror each other in terms of, you know, fraud aspects and that kind of thing. Really kind of understanding the practical implementation of some of these technologies as well will kind of help you from just a research perspective to see, okay, well, where is this actually being utilized and how could we potentially exploit something here to then kind of second order impact some other application of the technology. That's what I'd recommend, is really understand practical use cases of the technology and then dive deeper into specific tech after that.
Cool. Yeah, kind of like the layers. I think that's very much a cloud approach, right? It's like oftentimes you're working with abstractions on top of, it's like, okay, I can control this config here, which controls this command that's run in this Docker container, which is itself bonded to keys. There's like, you kind of have to think about layers of technology and the relationship and the second order vulnerabilities that occur. That's great advice. Hannay, any sort of thoughts out there for people? Obviously, I assume read the blog would be maybe one, or read the blog series would be one, but do you have any other sort of advice for those who maybe traditionally haven't spent a lot of time in Web3 and could take a path similar to yours of spending more time in it and diving into it head first and being able to author a blog like this or talk this detailed about Ethereum internals?
Yeah, like things are getting more accessible. I mean, they kind of always were in the most literal sense accessible because it was all public. And you know, you should send someone a link on Remix and they can execute your code and play with it. It's like easy as that. But it is getting easier. The tooling's getting better. We may be working on some tooling in that regard. But you know, things like a good example of like getting a testnet sorted. I think BuildBear, it's a new tool just released where it allows you to fork off of any network, testnet or mainnet, and just have that as your testnet provider. Yeah, and ultimately, like tools like Foundry, it's a very good fuzzing/testing suite. Everything's scriptable and packageable, so you can probably go on GitHub and you'll find many people trying to recreate these high-profile DeFi breaches by packaging everything up in a Brownie or a Foundry project, and you just clone that and set up a local testnet. Off you go, and then you can see like how the transactions are ordered. And so it is getting easier. Yeah, so I think Twitch is also very good. All of the big time contract auditors are quite vocal about what they do. So yeah, Twitter's a good resource. Various CTFs. I think Ethernaut is one that's good, and I think it's continuously updated.
Right.
Yeah, I think probably the one you want to start with is probably EVM, because even though the other chains like Solana, whatever, they are quite different in how they're like granularly implemented. Their overall ideas are the same. So yeah, I just say just learn EVM, learn Solidity, fork off some DeFi projects and testnets with some test tokens, and just prod around with it.
Cool. Yeah, I think CTFs were like the first introduction for me, and it was really exciting. There was something, it was very approachable, like initially up front. The only complexities, the base complexities you have to get out of is just thinking about like contracts being compiled and then bytecode being put on a chain and like your execution of that code occurring on a node. Once you get that separation out of the way, it's really just code. It's like open source code that you get to exploit, which is, to be honest, my favorite part of research. That's like my favorite place to be in, because there's something great about sitting on the balance of the developer who built it and you as an attacker thinking about attacking it, and both of you have the exact same information, and it's just the context you draw out of the code, right? Like you're both looking at the same source and you come to different ideas about its security. I love those.
So
Excellent.
you did say something earlier that kind of weirded me out as a researcher, and the idea of kind of undisclosed public exploit code being publicly available on the chain. I don't know. I usually keep it pretty close to the chest if I find something in a kind of public platform or vulnerability, anything like that.
Mhm.
Usually it's kind of a small circle of people that I will disclose to internally here. Be like, all right, you think this is a thing? Should I report this? Is this a deal? And then my thought of, having all of that publicly exposed out through a chain that everybody else could then start looking at and poking with, and then potentially exploit or publish or, kind of beat you to the punch on that.
Yeah.
A little scary as a security researcher. So I thought that was
Yeah.
kind of interesting.
Yeah, it's definitely a novel. It's an interesting space. It's got like some similar components, but some novel sides too. It's, you're doing this sort of research in a very public and highly dynamic space. You're doing it in a space that's doesn't feel so much like hacker in a basement, but more like hacker in a crowd. Like a lot of the vuln research or covering real world exploits, they look at vulnerabilities that happened and they have the full transaction history. It's like hours after a big hack occurs and a bunch of money is stolen, there's Twitter threads detailing out like what happened, and people can look at those transactions. So it has some downsides, but I think it also has some benefits too. It's like there's a lot of transparency in the process. So it's like every single hack, assuming it was executed on a public chain, has a trail, right? Like you can look at the transactions and hopefully come to some conclusion about what occurred, as opposed to it being blind, right? Like Equifax gets hacked and nobody really ever knows the details because they get to control exactly what got released.
Yeah, Microsoft sent an email out to a whole bunch of tenants warning about some guest access and roles and everything. And a bunch of us were kind of speculating on Twitter, like, well, was it you? Was it you? Like, who did this one? Because I want to know what's going on and why I got that email.
Right. Okay. Awesome. Well, I think with that, we'll draw this episode to a close. If you would like to follow any of the blockchain or DLT research, we'll have a lot of stuff coming out on our blog. Hannay, Mohanna, and Connor Taylor. Obviously, big thanks to both of these gentlemen for being here. They are extremely smart, and I'm sure they'd love to talk to anyone about DLT security. Obviously, thanks to Karl for being here as well. Fortunately, we couldn't get Scott. Hopefully, he's on next time. And we hope everyone enjoyed this episode of Hack Responsibly, and good luck out there looking at Web3 technologies.